All right, we're going to talk a little bit about data tiering today, and data tiering is clearly not new. It's been around since the inception of data storage. But the way that we do data tiering and the level of manual intervention has changed dramatically over the past few years. So what I've drawn here are basically 4 different scenarios of data tiering. And in our upper left side, we have basically what I'll call a manual data tiering. And everybody has this type of implementation and has had this type of implementation at one point or another. And you might have a single storage array that might have 3 different geometries of disk that represent fast, medium, slow, high cost, medium cost, low cost, etc. So I have those represented here by 1, 2, and 3. Now, what this represents here is that data has a value associated with it, and higher value data or more current data is typically going to reside at a higher level of tier because that's the active data that gets utilized on a day-to-day basis. Whereas older data or data of less value is going to get pushed down through the hierarchy to a lower tier. In the older architectures, it was a manual process to move that data from tier 1 down to tier 2 and then ultimately down to tier 3 and then maybe off to disk or for deletion. But the problem in manual tiering is it was a human process. Somebody had to choose the data and say, I'm going to move data from 1 to 2 and 2 to 3. And if he was lucky, no problems. But if he was unlucky, chances are the telephone rang and somebody wasn't getting the service that they needed. So that did present some challenges. About 10 years ago, we introduced virtualized data storage. And what that was, in this picture here, I've depicted 3 separate arrays that have tier 1 and tier 2, and this array in the center has a tier 1 and a tier 3 kind of an architecture, and the other has a tier 2 and a tier 3. And up above it, I'm going to have some type of a gateway device or maybe some piece of software that's going to allow me to aggregate these technologies into one giant pool of storage, and I can carve up those technologies the way that I want. So what I do is I utilize virtualization to allow me to do data tiering across platform. And the intelligence is being delivered at this level, whether it's software or whether it's gateway, to allow me to move data between tiers of architecture. But to an extent, it's still a relatively manual process. I'm just breaking down the barriers here of being able to utilize platforms that are also existing in my infrastructure that I may not have the highest level of utilization. About 4 years ago, grid architectures really came to the forefront. And what grid architectures introduce is the concept of giving tier 1 performance and tier 1 availability using tier 3 technology, which if you're successful at doing that, it begs the question, why do you need tiers anymore? And so there have been a few architectures that come to the table now that have massive arrays of spinning drives, maybe low capacity drives, but data is spread across so many of them and mirrored across so many of them, makes it very cost effective and very high performance, so you're able to deliver very high availability and very high performance using lower cost architectures like 7200 RPM drives, but deliver high performance. And that's really kind of a grid. So you basically have manual tiering, virtualized tiering, and then what I'll call a tier-less architecture. But the big concept that's hit the market now is this concept of automated tiering. And what automated tiering is, it is an automated movement of data based on activity of I/O between a higher level tier, which is either very, very fast drives, maybe 15K drives, or even solid state technology, and a very low capacity, or very high capacity rather, drive technology, but a lower performance. And what you'll note here is I've eliminated tier 2 altogether. So what this allows you to do is to move data based on activity between tier 1 and tier 3, such that you now can drive down the cost of your infrastructure by buying only a small amount of disks that are high performance in nature while serving your capacity requirement with lower cost technology. The benefits of automated data tiering is there's no manual intervention involved. The subsystem monitors the activity of the I/O and will move data accordingly to the highest level of disk in the subsystem, ensuring the highest level of performance for the applications. When that application no longer needs that data, over time that data will be migrated down to a much more cost-effective capacity and maybe a larger capacity drive, where that will drive down your overall cost of computing. So again, we have manual tiering, virtualized tiering, tierless, and automated data tiering. And the market is moving towards this automated data tiering model that says, let me take the human element out and let the subsystem tell me what's supposed to get the highest level of I/O and what's supposed to just reside on lower cost storage.
Please visit us at cimasg.com.